Hello everyone, welcome to my channel. Today in this session we are going to learn the decimal expansions of rational numbers. Okay, already we have learned in the previous classes that the rational numbers would be in either terminating decimal form or non-terminating repeating decimal form. Okay, which means terminating decimal form in the sense you can get the decimal point like this 1.0145. So this is terminated here at 5. But another type of decimal forms are there. Those are non-terminating and also the repeating decimal form. Non-terminating in the sense 0.1, 2, 3, 4 and so on. Whereas we have another type that is repeating decimal form. That repeating decimal form means 1.141414 like this. Here 14 is repeating always. Okay, these are the three types of decimal forms of rational numbers. We are going to consider a rational number. Let us take the p by q form. We are taking the rational number as p by q form, where q should not be equal to 0. Already we know. If it is equal to 0, it won't be a fraction. Okay, and we have to explore this rational number exactly when the number p by q, when this fraction is going to be terminating decimal or when it is non-terminating or repeating recurring decimal. Okay, we are going to check this fraction for either it is terminating decimal or when it could be non-terminating or when it could be repeating or recurring decimal. We are going to learn today. Okay, let us take an example. Like I am taking the example 0.80875. Okay, this is the example. I am converting this decimal number into p by q form. Okay, to convert that I am taking in the numerator. Here we have 1 after decimal point. We have 1, 2, 3, 4 digit we have, right? So here I am writing 875 directly. In the denominator here we have 4 decimal points, so I am taking 10 power 4. So this 875 can be factorized. When you factorized with the prime numbers, this 875 will become 5 into 5 into 5 into 7. If you take the prime factorization, you can calculate in the rough work. That is 875. When you do the prime factorization, it won't be divisible by 2 because it is a odd number, and it won't be divisible by 3 because it is the sum of the numbers are not equal to sum of the numbers are not divisible by 3, so it won't be divisible by 3. So I am taking directly the prime number 5. So when you take the prime number 5, we will get here 5 ones and 5 sevens and 5 fives, 175, and again with 5 you will get 35. When you do again with 5, it is 7. So prime factorization will be 5 into 5 into 5 into 7. I am writing here, and the denominator as it is 10 power 4. This 10 can be written as 2 into 5. Again we are doing the prime factorization for the denominator also. Okay, so the numerator can be written as 5 power 3 into 7 divided by 2 power 4 into 5 power 4. When you simplify this one, you will get here cube of 5 is there, here power 4 is there. 3 5s will get cancelled, only the one remaining in the denominator, that is 7 upon 2 power 4 into 5. Okay, on simplification you will get 7 upon 80. This is the simplest form of 0.0875. Here we are converting this decimal form into the p by q form, where this p and q should be the co-primes, not only for this decimal but also for every terminating decimal can be written in the form of P by Q. Okay, and you should remember that P and Q are should be co-primes. Okay, P and Q numbers should be co-prime numbers, which means the any two numbers having only 1 as the common factor, those are known as co-prime numbers. Already you know, I think. Here 7 and 80, if you take 7 and 80, there is no such common factor other than 1 for 7 and 80. Okay, so those two are the co-prime numbers. For any decimal form, we can write the decimal form in the form of P by Q, where P and Q are the co-prime numbers. This is the first method of decimal expansions, in which the decimal form is terminated one, and other two we have, that is non-terminating and repeating. Let us see those two. Before going to the next one, from the above example, what we can observe, this is the theorem. Okay, let us see. Let x be a rational number whose decimal form is terminates. That x is the value, that is we have taken here 0.0875. This is x. And then x can be expressed in the form of P by Q, where P and Q are co-prime. So we have expressed this in the form of P by Q, that is 7 by 80, where 7 and 80 are co-primes here, right? 7 and 80 are co-primes because there is no common factor for those two other than 1. So, and the prime factorization of Q is of the form 2 power n 5 power m. Okay, when you factorized in the denominator, you have 2 power 4 and 5 power 4. This is in the form of 2 power n and 5 power m, right? Where m and n are the non-negative integers. Yes, here 4 is a positive integer, it is a non-negative integer. This is the theorem statement from the above example. Clear? Up to now we have seen the conversion of decimal form, terminating decimal form into the P by Q form. Now we'll discuss the P by Q form to the decimal form. Okay, how can we convert this P by Q form to the decimal form? Let us see that example. Okay, let us take this example which is in the form of P by Q. Actually, we can do the actual division and we can write the decimal form of this 25 by 2, but without using without using the actual division. How can we find the decimal form of this P by Q form? Okay, now let us check that. So first you have to write the factorization, if any will get. Okay, so here 25 can be written as 5 into 5, and upon only 2 is there, I am writing 2 as it is. But whenever you want to convert this number into the decimal form without using the actual division, you should convert the denominator into 2 power n and 5 power m form. Okay, to convert like that, already we have 2 power n form, we need another 5. So I am multiplying and dividing with 5. Okay, then only here 2 power 1 is there, so we can write another 5 power 1. So I am dividing and multiplying with the 5. So we will get 5 into 5 as it is, another 5 I am multiplying, and also I am dividing with the 5. Clear? Now how can we write this? 5 into 5 into 5, which is 5 cube, upon 2 into 5 is 10. 5 cube, value of 5 cube is 5 5s are 25, 25 5s are 125. 125 upon 10. Okay, how can we write this in the decimal form? When you have the 4 digits after decimal, you have taken 10 power 4 in the denominator. In the same way, if you go backward, here in the denominator we have only 1 0. So only of before the 1 digit we will get the decimal point. So we can write 12.5. Okay, this is the decimal form of P by Q form without using the actual division. Clear? So from this example what we can say, if the denominator can be written in the form of 2 power n and 5 power m, then the value, the decimal form which we can get will be the terminating decimal form. Okay, the same theorem we can apply here, but little bit change. That is, if you write the denominator in the 2 power n and 5 power m form, that is a terminating decimal form. Okay, that we will get the terminating decimal form. Till now we have discussed the terminating decimal form. Now we are going to discuss non-terminating recurring decimals in the rational numbers. Okay, so let us take an example here to understand clearly. I am taking the example 2 upon 7. Okay, is this non-terminating or terminating? We will check. Okay, by using the actual division method we are going to find the result for this. Okay, how can we find the actual division? Divide with 7. Here it is 2. 2 is not divisible by 7, so I am taking 0.000. You can take other zeros afterwards or else some more. Okay, now it is 20. When you take here 0 point, here also you have to take in the quotient. Okay, 0 point something. Now here we can take the 20 together. Okay, let us consider this 20. 7 2s are 14, 7 3s are 21, so we can't go behind the 20, so 7 2s are 14. Okay, so when you subtract this from 20 you will get 6. Another 0 I am taking down here. 67. With 7 it is 7 8s are 56. So when you subtract again you will get 4. Another 0 I am taking here. 7 5s are 35. So when you subtract here 5 and the remaining is 0 I am taking. 7 7s are 49. 1 remaining, and when you take 0, 7 1s are 7. When you subtract 3 you will get 30. 7 4s are 28. Again 2. 0 I am taking down. 7 2s are 14. So again 6 will remain. So here at the first we have 2. Here also we are getting 2. The next is 6. Next is 6. So after this the remaining terms are repeating. Means 2 8 5 7 1 4 is repeating always. Okay. So from this what we can say, the 2 by 7 can be written as 0.285714 bar, because it is repeating, so we can take the bar. Here what we can say, we can notice that the block of digits, which is the block, that is 285714, this block of digits is repeating in the quotient. Again if you take the further division you will get the same numbers repeating here. Okay, so this block is repeating, so we can say this is the non-terminating recurring decimal. And also we can say in the previous one what we have discussed, when the denominator is in the form of 2 power n and 5 power m, then only that is a terminating decimal. When you take the denominator in this example, this is 7. 7 can't be written in the form of 2 power n into 5 power m, right? So it is a non-terminating and recurring decimal number. Okay, clear? So from the above example we can state the theorem that let x be P by Q is a rational number. Okay, we have taken 2 by 7 is a rational number such that the prime factorization of q is not of the form 2 power n and 5 power m. Here the 7 is a denominator, so we are considering this as q. So the prime factorization of this denominator is not in the form of 2 power n and 5 power m, where n and m are non-negative integers, we know that. Then x has a decimal expansion, that is 2 by 7 has a decimal expansion which is non-terminating repeating, right? We are getting the same. It is a 2 by 7 is a non-terminating repeating decimal because the denominator is not factorized in the form of 2 power n and 5 power m. This is a simple statement of the theorem. Here we have the two problems, that is write the following rational numbers in the decimal form and also state which are terminating and which are non-terminating repeating decimals. Okay. Now without doing the actual division, you need to find whether these two are terminating or non-terminating repeating decimals, right? So I am taking the first one. This can also be written as, this is a mixed fraction, so I am converting into the proper fraction. So 5 into 4 plus 1, right? 20 plus 1, 21 upon 5. So now I am taking, so when you are going to say this number as a terminating decimal, when the denominator can be written in the form of 2 power n and 5 power m, then only we can write this as a terminating decimals. Here we have in the denominator the prime number 5. So you can multiply and divide with 2, then you will get the 2 power n and 5 power m form in the denominator. So let us do that. 21 can be written as, or else keep it like that, 21 into 2 upon 5 into 2. Okay. So 21 into 2 is 42 upon 10. So here we have only 1 0 in the denominator, so we can take the one digit, the decimal point before the one digit, so it is 4.2. this 4 1 by 5, this fraction can be written as 4.2, which is a terminating decimal because the denominator we can write in the form of 2 power n and 5 power m, whereas when you take 2 by 11, here the denominator itself a prime number which can't be written in the form of 2 power n and 5 power m. So directly we can say this is the non-terminating repeating decimal. Non-terminating and repeating decimal. If you have any doubt, you can check it with the actual division, that is 11 with 2, it is 0.11. we are taking here 2 is not divisible by 11, so I am taking 20. 11 ones are 11. Here the remaining number is 9. Again I am taking 0 here. 11 8s are 88. So when you subtract this one, you will get 2. Again 20. 11 ones are 11. So when you keep on dividing like this, you will get 0.18181818. So the result is 0.181818 and so on. Here the block of digits 1 8 are repeating continuously, so it is a non-terminating repeating decimal, whereas 4 1 by 5 is a terminating decimal. In the same way, next we have without performing the division, means without performing actual division, state whether the following rational numbers will have terminating decimal form or non-terminating repeating decimal form. Okay. So first of all, you should remember that the denominator should be in the form of 2 power n into 5 power m. Then only that number can have the terminating decimal form. So let us take the first one, that is 11 upon 12. This can be written in the form 2 into 2 into 3. When you do the prime factorization for this one, you have 2 into 2 into 3. Here 11 upon 2 square into 3. Here we have 2 power n form, but we don't have the 5 power m form. So it is a non-terminating repeating decimal. It has non-terminating repeating decimal. Okay. And when you take the second one, that is 64 upon 455. So 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. That is 2 power 6 upon 455 can be written as 5 into 91. Okay. Here in this also we have 5 power m form, but we don't have the 2 power n form. So it is also non-terminating repeating form, that is 2 power 6 upon 5 into 91, which is also non-terminating and repeating decimal. And the last one, 9 upon 15. This can be written as 3 into 3 upon 3 into 5. These two will get cancelled. 3 upon 5. Here in the denominator it is 5 power m form. So we can say that it has terminating decimal. Okay. This is the simple way to find whether the given number or given fraction is a terminating decimal or non-terminating repeating decimal without doing the division. Next bit is write the following rationals into the decimal form. Here also without using the actual division. So when you take the first one, we have 13 upon 25. Okay. First of all, you should write the prime factorization for the numerator and denominator. Here in the numerator we have already the prime number, so let us take like that, and the denominator can be written as 5 into 5, that is 25. Okay. If you want to convert this number into the decimal form without using the actual division, the denominator should be in the form of 2 power n and 5 power m form. Here we have only 5 power m form. For converting this number into the decimal form, you should multiply and divide with the 2 power n. That is, here we have 5 square and we should multiply and divide with the 2 square. Okay. 13 into 2 square upon 5 square into 2 square. This can be written as 13 into 4 upon 5 into 2, that is 10 square. Okay. 13 fours are 52 upon 10 square is 100. Here in the denominator we have 2 zeros, so you should take the decimal point before the two numbers. Okay. You will get 0.52. Done. Okay. Without using the actual division, we have calculated the decimal number of the given p by q form. And the next problem is 23 upon 2 cube into 5 square. Here in the denominator we have 2 power n and 5 power m form, but those powers are not equal. To equalize the powers, I am multiplying and dividing it with 5. So we will get 2 cube into 5 cube. 23 into 5 is 115, and in the denominator we have 10 cube. Okay. So 115 upon 1000. Here in the denominator we have 3 zeros, so we have to take the decimal point before the 3 digits. So the result we get 0.115. Okay. In this way you need to calculate the decimal form of the rationals without using the division. Clear? Thank you for watching my video. Please follow, like, share and subscribe our channel from Innovative Thoughts for more videos and for the complete mathematics course for the 10th class.